Distinguished guests, ladies and gentlemen, the Korea AI Summit 2022 will begin shortly, and as the conference will start at 10 o'clock, if everyone could come in and take their seats, we'd like to get started. Also, during the conference, please make sure that you wear your mask properly to comply with the COVID-19 preventive measures. And we would also appreciate if you could put your mobile phones into silent or vibrate mode. Thank you very much. Distinguished guests, ladies and gentlemen, welcome to the 2022 Korea AI Summit. My name is Jessica Park, and I've given the privilege to host today's conference. First of all, I'd like to express my deepest gratitude to all the participants for joining us here today out of your busy schedules. Today's conference is hosted under the theme of AI for Good, aiming to allow everyone to think about the present and future of artificial intelligence technology and its related challenges, as well as countermeasures, by having a close look at examples and insights shared by AI experts at home and abroad. In addition, the Korea AI Summit 2022 is taking place both on and offline, and you can live stream the conference on our IITP Naver TV or on our YouTube channel. And I am very delighted to broadcast the event, as we will be able to share our fruitful discussions with a lot of audience. First and foremost, there will be a panel discussion on the topic of recent advances and challenges in AI and ML for healthcare and climate change. We'll begin the panel discussion to take a close look at diverse views of AI experts at home and abroad. And those of you joining us online, if you'd like to leave us a question, you can also leave your question. You can access the online page by scanning the QR code. And in the discussion, Ms. Alice O, professor at KAIST, will be the moderator. So, ladies and gentlemen, please welcome her with a big round of applause.
Okay, hello. Just want to make sure that I'm heard. You can hear me. All right, so thank you, the moderator of this entire thing, for introducing me. And I will now introduce our three panelists. We have Finale Doshi Velez, who is Gordon McKay Professor in Computer Science at the Harvard School of Engineering and Applied Sciences. Let's welcome Finale. And then in the middle, we have Professor Ham Yu-gun, who is in the Faculty of Earth Science, System and Environmental Science at Jeonnam National University. And last but not least, we have Professor Edward Choi, who is a professor in the KAIST Graduate School of AI, right next to me. Okay, so we have a lot of important problems in our society, right? So in this big question that we're trying to answer today, how can AI be used for the good of our society and humanity? Right? So among the many serious and important questions, we today in this panel are tackling two of them broadly: healthcare and climate change. And I think we all know the seriousness of these two problems. So let me first begin the panel by asking our panelists what they do for this research area of applying and developing AI and machine learning technologies for healthcare and climate change. Let's begin with Finale.
Thank you. It's a pleasure to be here. So my research from a technical perspective has to do with probabilistic modeling, reinforcement learning, and interpretable machine learning systems. And all of these are important for the types of healthcare problems that I work on, which is largely looking at what types of treatments are going to be best for which sets of patients. So when we're trying to do this, we have large collections of electronic health records, for most part, that we're trying to analyze retrospectively. So we have all of this data that's already being collected by what clinicians are already doing. And the question that we want to ask is, could we be doing better? Where are the situations in particular where clinicians sometimes make one choice and other times make a different choice? And that gives us the statistical opportunity to identify, which choices might be better. Now, as we've been doing this work, another really interesting area that has come up, kind of related to the interpretable machine learning aspect, because so far we've mostly has to do with decision making under uncertainty, is how will people react to the choice? Because ultimately, it's not the machine that is going to be treating the patient. It's not even just a single doctor that is going to be treating the patient. There's a system of nurses and care team and doctors and family, friends, et cetera. And we look at just a tiny piece of this in terms of how will people respond to explanations provided by an AI system, and look at how do we make sure that people don't over-rely, for example, on AI evidence. If you do this kind of blindly, people will just trust an explanation even more. They're like, the system is so smart. I must go with the system's recommendation, whether it's good or not. So that's another aspect I work on. And then the final one, which we can leave to discussion, is how should regulation around these systems be done? How do we make sure that they are accomplishing the goals that we want them to accomplish? How do we make sure that innovation is happening without kind of the mistakes? As you mentioned, this is a high stakes sort of domain. I'll leave it at that.
Okay, thank you. So next we will hear from Yu-gun.
First of all, thank you very much for inviting me. And my research area is about the understanding and predicting all various climate variability. So as you can see, some winter is very cold and some winter is quite normal, warmer than normal. And the kind of things that we are doing. And all the stuffs associated with all the weather and climate variability is now changing due to the global warming. So not only the increase in the global average temperature, so it affects all the other hydrological variables such as precipitation and the ocean currents and the temperatures. And this kind of impact of the global warming is quite nonlinear and complex, and it cannot be done with the previous or current methodologies we are now using. So in this respect, I'm applying the machine learning to understand the complex and nonlinear features of the global warming and its impacts through the machine learning.
Thank you. And Ed?
Oh, is it working? Yeah, so I used to work a lot on medical records, which is called electronic health records, which is a database from hospitals. So it's all structured tabular data and trying to use that to predict future diseases or recommend drugs and that kind of stuff. Since I moved to KAIST as a faculty member, I'm trying to expand that to incorporate a lot more information regarding different modalities such as pixel images like X-rays or MRIs or EKGs, time series data, that kind of stuff. So in order to get a comprehensive information of the patient to make a most informed decision. So how do we do about that, and how can a machine understand all these different modalities of a single person's medical record, and how can you evaluate whether the model actually understands what it sees? So regarding that, I'm trying to tackle that in different aspects, predictive modeling as well, and also interpretability and question answering, a dialogue, and most of them are related to natural language processing as well. And another thing that I'm interested these days is how can we translate what we've developed in the lab to the reality, to deployment, and what needs to be done to make sure that it doesn't harm people. So interpretability, reliability, out of domain distribution detection, those keywords are very important. So those are the things that I'm researching these days.
Okay, so I forgot to emphasize how great it is to have these three experts. These are people who are very difficult to get together, I think, in one room, and I managed to do that. So I applaud myself. So let me begin the second question with Ed. So you were mentioning how you were previously at Google, as far as I know. So you were at Google working mostly with EHR data, and now you're working with more modalities, and so to get perhaps like a more comprehensive view of patients and diseases. So I want to ask you, what were your recent successes? Is looking at multiple modality, is it really leading to more, better results? Or are you making progress towards that? So can you tell us about your recent successes at Google and also at KAIST?
So at Google, I wasn't particularly interested in multimodal learning yet. So I kept doing on what I was doing during my PhD days. So it was kind of like tying things up in a nice manner before I left Google. So the multimodal thing became my interest when I moved to KAIST. And I'm not sure if I can call it a recent success, because I'm not sure if any of my work has actually impacted patient in a patient level, maybe in an administrative level, trying to do like risk assessment or like decision support system, that kind of things could have been hopefully impacted by my work, but I'm not sure if it's actually changing the lives of the patient yet. But the recent success, or something that is close to success, is when we look at, for example, X-ray and the report, which is one is pixel image, the other is natural language text. If we look at the two at the same time, we can bring new values that weren't possible before when we were only looking at one modality, such as writing reports automatically just by looking at the X-ray. The machines can actually do it quite well with like large language models, especially these days. So it can help doctors, take their burdens less, so that they can focus more on the patient, or maybe more looking at the pixels rather than trying to copy paste everything that they say over and over again. So that was one of the values, and also retrieval systems can be extended in multimodal manner. You can input a image and then try to retrieve the most relevant text, or vice versa. That kind of stuff can also be done. So not sure if, and also obviously diagnosis is way more accurate with two modalities at the same time, but then can we actually make those diagnoses like impact patient lives or patient care quality with those diagnoses is still in question. So I'm not sure if I can claim that as a recent success, but the other values that I just mentioned was quite interesting, even as an ML researcher perspective.
Yeah. So later on, we are going to get to the challenges and the next steps in actually making real impact to saving more patients or giving them more healthy lives. But thank you for highlighting that. Uh, I think those are actually successes or like steps towards that goal, right? So maybe Finale, you can expand, since you also work on healthcare, what you thought about what Ed's just said, or add on your perspectives and your successes.
So I honestly, I feel similarly. I can't claim to have impacted patient lives, even though I really want to at some point. Maybe N years down the future, I get invited again to this panel, and I will be able to say, now we have accomplished this. If I look at the impact that I've had in like healthcare, like one of the things that actually recently that I'm quite excited about is this thing that I mentioned where we've started really looking at where doctors disagree as like the key place where we could make a difference. Because when doctors disagree about how to treat a patient, that is the only place in the data where we have basis to make a recommendation, because sometimes a patient who looks like this was treated one way, and sometimes the patient who looks like this is treated another way. So I'm kind of proud of the fact that my clinical collaborators, for the first time, they were like, Finale, this idea makes sense. We like it. It's going to make a difference at some point. So that's something that I'm kind of proud of in terms of recent successes. But also, I wouldn't discount the administrative successes, because our doctors really need to be spending time treating patients and not doing stupid paperwork. So I think that that's a big deal.
So I want to ask Finale a question to follow up for that. So when doctors disagree and you give them some recommendation from the machine learning system, do they accept that, or would they argue with what the ML is saying?
So one thing that we have done, this is not with patients, but we did do a study with 200 psychiatrists, which is a fairly large sample size in the healthcare world, where we provided them a description of a patient, and then we asked them to recommend which antidepressant the patient needed. And we had an expert panel to determine what were the correct answers in this case. And we found that if you provided an AI recommendation, and other people have found similar results, that they very much over-relied on the recommendation. Because we created the experiment, we could give an incorrect recommendation on purpose just to see what happened. And they would go with the recommendation, and providing explanations sometimes helped. The more annoying explanations helped the most. Annoying meaning they took time to read, but because they took time to read, people paid more attention, and they were like, oh, this seems weird, and they noticed the error. So actually, a new direction that we're focusing in my lab now is how do we balance like annoying people by asking them to really pay attention to the information we're giving them, with they need to get on with their day, and they don't want, we want good decisions, but we don't want people to get so frustrated that they'll not want to engage with the system.
Yeah, that's very interesting. It's kind of mind-boggling that they would accept the system's recommendation even if it's not necessarily the correct recommendation. What do you think?
We always, we're busy, right? And there's there's a study from the 90s actually, where, from the 2000s, but looking at work from the 90s, where this is not us, this is just published out there on mammography. And there was a system to help with mammography, early detection of breast cancer tumors in images. And it worked well enough that it was taken up by Medicare and Medicaid, was widely adopted. And then people, when they did the studies in the 2000s, found that it actually reduced the ability to detect the tumors earlier. Because what was happening is that when people were called in to do the study, to test the system, they were very careful. They had taken time out of their day. They were relaxed. They were like, okay, I will look at the system, and then I will look at my own thoughts on this image. And they would find the system would catch things that they wouldn't, and they would catch the system's mistakes, basically. And so the performance was better. But once it was put out into the real world, they're just having to go through a bunch of slides, and they were too busy. And
Yeah. So I think that connects us to, the underlying problem that this is not just a technical or research problem, but it's really much more complicated than that.
Can I add to that point,
Yeah,
actually?
please.
Because I started out in terms of as a reinforcement learning researcher. I thought reinforcement learning in healthcare means finding better treatments for patients, right? It's kind of obvious, right? Like, what's the action space in healthcare? It's treatments. Now I'm starting to think that that's still important, but a big part of the action space is what sort of information and nudges do you provide to people so they will make good decisions? And so I think it's still a technical problem. I like, as an RL person, I'm still excited.
Thank you. So let's switch gears a little bit and talk about climate prediction and what your recent successes have been.
Yeah. So my success is not on saving people's lives. Sorry about that.
In the long run.
And my recent success, I'm not sure we can call it as a recent. So there's various kind of climate variability. So which oscillating for every 2 years, 3 years. So we call it all the climate variations. And the most representative climate variability is El Nino or La Nina. So you might heard of that. So the forecasting El Nino or La Nina, so we call it as an ENSO as a whole. And it's very important. It has a global impacts, for example. So it has a quite robust impacts in U.S. and also East Asia. So predicting that kind of climate variability is quite important for the global climate variation forecast. So I developed the model, which is basically based on the convolutional neural nets to predict the ENSO and more than 1 year advance, and it's overcomes the limitation of the previous methodologies, which is based on the climate. So we call it global climate models, which is based on basically the computer programming, which simulates all the cloud process and precipitation processes. So the global climate model itself has errors, systematic errors, because all the natural variation is programmed. So that kind of limitation is overcome using the machine learning. And so some people think that for forecasting the climate variability is not that important as it's not as the whole. And we are talking about the climate change. So nowadays, and people are tackling the machine learning, so tackling the climate change and use it as a machine learning. So for the climate change or global warming issues, it's very difficult because we don't have any observations, because have to predict the future we never experienced yet. So for example, the global warming impacts after 10 years or 20 years is very hard to validate. So the limitation and difficulties comes from that. So on the other aspect, so what we are doing is that what happens during the previous 30 years, 40 years, and the system is changed during changing during previous 30 or 40 years. So we call it as climate change detections, whether the whole system is significantly changed for recent 30 years due to the global warming. So that kind of issue is quite new. So we have been doing it for a long time, but so applying the deep learning and machine learning to tackling this problem is quite new. So it's never been successful so yet, but so we are making the small progresses. So not only the increase of the surface temperature, which is quite popularly known for everyone, but all other the variables, such kind of precipitation it varies very large day to day. So that kind of variation we are also experiencing the impact of the global warming. So that kind of issues, so we are now tackling, and we made some progress. So it's now we are working on it.
Yeah. So very interesting, and also it's very important for us to be talking about this, I think, as a community, and perhaps many of the researchers in this room, especially the student researchers, for them it's even more of an important problem when we look to the future, let's say 30, 40 years from now, and what our climate situation is going to be. So I want to expand on some of the challenges that you've already outlined, but to me, and I know very little about climate change, so you can, so my question might be somewhat naive. So you mentioned at the beginning, so this whole area of climate prediction has many important variables like the surface temperature, the clouds, ocean currents, and it seems to me that you will need different types of data, different types of machine learning methods for those different variables, or is there like a big unified machine learning model that actually can model all of these aspects together? And if so, what are the specific either data set or machine learning methods challenges in climate prediction as a whole?
Yeah, that's a very good question, so we are thinking so for the climate scientists or the atmosphere scientists, there are several variables which we are thinking as a key elements, like surface temperature and the precipitation and the wind, and some kind of key variable we are having. So the observing those variables are the number of observations to observe that kind of variable is now increasing, and nowadays it covers most of the globes. So we have some backgrounds and plenty number of data to tackle that issues, but to formulate the deep learning or machine learning model, we have to. So there are two strategies going on. Just putting all the variables we are observing and make the forecast, and that's the one strategy. And for that, we have the plenty number of data to train all the relationship between the other variables and something. And the other strategy is to select a few of them and make the forecast which is much more targeted. And that two kind of different strategies going on at the same time. And nowadays, so for a long term, so putting all the variables and making the outputs for all the variables, and now it can go iteratively to make the long-term forecast. That kind of strategy will be dominated. But nowadays, the strategies which selects few key variables and make the few targeted phenomena is also doing at the same time.
Okay, so let's switch back again to healthcare, and maybe Ed can tell me what are the challenges that you're facing. There could be the model challenges, or it could be the data sets, or the people that are working with these data, or the policymakers. So it could be a variety of different things. So what do you think?
I'd like to follow up on what Yugen just said about two different approaches. So what Yugen said is that if you have domain knowledge, you can select key elements and then try to exploit it into making some targeted predictions, which is what I think a lot of healthcare researchers have been doing so far in ML space. And as Yugen said, maybe in the future, putting all the variables, putting all the information into the single model and making hopefully the model makes an informed decision would be a dominating methodology, which I kind of agree. So that's the thing I'm doing these days, which is maybe like even a couple years ago, when you look at the electronic health records, there are certain things that you as a non-domain expert know that's important, like drug names or drug dosages or medication instructions, treatment names, diagnosis names. Those are apparently important, and even I know that. You don't have to go to a doctor to ask if those are important. So I used to extract those information from the patient record and then use them to make informed predictions and stuff. But these days, I now humbly accept that I have no domain knowledge at all, and I try to put everything in the medical records into the model and see if it works. And surprisingly, it kind of works, because if you think about electronic health records, it's just natural language. It's more structured natural language. So if you put all the text and put all the information from the database into a language model, or like large language models or pre-trained BERT-like models, then it kind of understands what's going on. So trying to expand on that, the problem is that engineering challenge arises, because you can only put so much data into a model before you blow up your GPU, and then comes a engineering challenge where you have to parallelize your model, distribute your model into multiple servers, and those are the kind of things that I don't think a single lab can pull off, especially with the large language models these days. Those are very, very advanced stuff. You know, like maybe OpenAI and Google, and those very, very few select companies can pull that off. But I think those technology will be necessary even in healthcare space sooner or later. And my concern is that can we, as a single group or like an academic institution, somehow utilize the technology or even accept the technology and then show that it works in niche domains like healthcare or even climate change as well. So that's one of my concerns. And another could be healthcare specific. And I'm sure it's a bit different in the United States, but in Korea, privacy is, well, I mean, privacy is an important issue both in the United States and Korea, but the legal systems are a bit lagging in Korea. So as far as sharing like healthcare data goes, United States have something called HIPAA, which is that if you're a healthcare institution and you own certain private information, patient records, if you follow HIPAA and then anonymize your data and then release it for research purposes or some collaboration, then as a hospital, you're protected by HIPAA. So if anything goes wrong after you release the data, if anything goes wrong, you're protected by the HIPAA rule so that you don't have any legal repercussion. But in Korea, we don't have that kind of stuff yet. So the hospitals are extremely discouraged to share data because it's their neck. If something goes wrong, it's all on them because there's no law protecting them. So hopefully, I'm hoping that government entities are working on some kind of regulations or protective measures such as HIPAA that is customized for Korean cultures and Korean society. But something that I cannot really comment on because it's it's above my pay grade.
Okay, so it's above your. I think you will get to that pay grade very soon. I think Finale might have something to say about both of the. So the first thing that you mentioned is having this large model that integrates all of the. I mean, what comes to my mind as somebody who works on language is that there could be spurious correlations, and which may or may not be a problem. And I know that Finale works with another type of model. So on modeling and also this issue of privacy and policy and other challenges that you
yeah, I was going to say I want to respectfully take a bet of like whether we're going to be dominated by one large Uber model down the road or whether it's going to be more of these domain specific domain knowledge models. And because the specific technical challenge I see, so part of it is validation. So I work a lot with interpretable machine learning and transparency. And the more honestly I've worked in the healthcare space, the more convinced I am that we need transparency in our models because of the spurious correlations that you mentioned. We've learned stuff like, if you have UTIs and pregnancy and are pregnant, then maybe recommend Prozac if you're also depressed. And it has nothing to do with UTIs or pregnancy. It actually has nothing to do with having female biology, which you might think is the first guess. It's just that OBs and gynecologists prefer to prescribe Prozac because it's the safest drug out there, and we're just replicating a pattern that's in the data. And there's loads of other examples. So I think that if we're trying to make recommendations, we need a certain level of transparency to validate them. And I don't think that's going to go away. But the other piece where I think we really need that transparency, and so I think the challenge is really like how to integrate domain knowledge and also how to get high performance that is still interactive, is that I don't think we're going to ever capture enough information about the patient. Take a depression, for example. There's lots of antidepressants, but some will make you fat, some will make you not able to sleep. All sorts of things will happen. And some will interact with things that are not in your medical record at all. And so figuring out what's the right information, what are the right inputs for a particular individual, I think is difficult. And then defining the reward function, like what is success? Like what does quality of life mean in the healthcare space is also not easy. So I think we're going to need to really think about how to build these interactive, transparent systems, which I think is a really cool technical challenge, right? So I think this is a cool question to do that. And then on the policy space, what I'm going to say is that like for everyone in the room that's interested in these big problems, I think as a community, we need to think really hard about where our research is going. Like, are we just publishing the AMIA, the JAMIA, the NeurIPS, the ICML papers, or are we at least setting things up to make a difference? Because, you know, like, if you care about health, you know, let's say you're someone like me. I care about healthcare, but I also really love doing math, right? And so the question is, like, how do I combine a passion for doing new math with wanting to do good for society? So I'm not going to be the therapist or the doctor, because that's not the thing that I want to do. And we need an ecosystem, right? We need an ecosystem of people trying to make change. But similarly, but I can't just sit there and do my math, right? And say I published a paper on it. Now hopefully someone will use it, right? And I think that's where I see a big challenge of, like, how do we bridge these sorts of papers we're writing to actual use cases?
Yeah, many good questions. And the keywords that I've heard from all three of you, I think, transparency, explainability, people need to actually use the technologies that are coming out of our research labs in order to really be able to make an impact. So if my next question is about your wishful thinking. So if you can, if you have the powers to do everything, right? And you really want to, and this is, you know, I'm taking it for granted that all three of you really want to solve these problems, right? We want to solve the problem of healthcare. We want to solve the problem of climate change. So if you were God, if you knew everybody, if you can make them do stuff, what would you do? What are our immediate needs? What are some of the medium-term and long-term steps that we need to make? Is it developing more technology? Is it gathering more data? Is it making better policy? And we've touched on some of these, but maybe you have some specific ideas about how we can move forward. So Ed, you want to go first?
I really love the question because I've been thinking about how to bridge the gap between what I'm doing and what people will be hopefully using maybe down the line, like maybe next 5 years or 10 years, is that we've talked about this on the email thread with Finale, and the technology, there could be a lot of things that can be done, that could be done with current technology. We don't need like next level AI there are a lot of current problems that could be solved in healthcare space, even with the current technology that we have. It's just that we don't have the drive for it, or we don't have the motivation for it, or maybe the stakeholders there are too many stakeholders. So don't want to get too technical or political for that aspect. If I had the power to convince some very powerful people to do stuff, I would ask them to come up with a test for. I'm only speaking in terms of healthcare. I don't know anything about climate, so only healthcare. For healthcare AI models, a test for healthcare AI models, like college entrance exams or medical license exams, there could be a test or national level test that could be used to evaluate the reliability of, I wouldn't say explainability. The terms are a bit blurry, like explainability, interpretability, anomaly detection, out of distribution detection, distribution shift, robustness, reliability. I think those are all kind of like, there are very blurry boundaries between the concepts. But when I say reliability, I mean that we don't want a model to harm people at all, like hopefully, ideally at all. So like, how do we know that the model will never harm people? Is that we need to develop a test that is certified by doctors community. For example, maybe an AI model that only focuses on X-ray, AI model that only focuses on MRI, like very small set of problems that an AI can handle, and then develop a test for that specific domain. And if the model passes the test, then it is certified, it is validated, its reliability is validated, and maybe get the doctor's stamp on it, like this is good to go. So, and the way that we need to construct this test set is just like how we test a student's capability to study in college, like in college entrance, in 수능 시험, we have so many, like X number of questions to reliability estimate the student's capability of learning, and then we have different diverse set of questions, and we need to do the same thing for the AI test. There's like we need to ask X number of questions on Y number of different domains or the Y number of different challenges, for example, to test reliability, to estimate or yeah, I would say estimate the reliability of the model, whether the model is good to go or not, right now into the practice with doctor's stamp. So I think it could be like a national thing, maybe once a year. You can't have the test every single day because then the models will be able to game the system. You have access if you can enter the challenge infinite number of times. You can game the system. You can estimate the distribution of the questions. So it has to be like maybe once a year, maybe 2 times a year, like a national level test where all AI models gather, solve the same test, and then whoever passes the bar with some, I don't know, 90% score or 95% score, then they're good to go. So I think that could be a good start to actually see what are the current technologies what the current technologies can do right now, even without actually going to the next level, like the AGI, that kind of stuff.
I see. I see. That's an interesting idea of potentially controversial, I think, because we know the downsides of standardized testing, at least for education, and also I'm worried maybe like communities like ML4H have data sets and benchmark data sets to do this, and the technologies that can perhaps pass the test at some level. But yeah, so I should ask Finale what you think about this idea.
Say, like, I feel like the spirit of your idea is exactly spot on. So I don't think it's controversial. Well, is it a standardized test or not? I don't know. But what I think we really need is building the substrate, the infrastructure for basically development and deployment and evaluation, like monitoring, evaluation, surveillance, post-market surveillance, basically. So, I mean, right now when we and I feel like in that sense, I mean, this is my first time in Korea, but Korea is a relatively small and very organized country. So, it's like there's possibilities here that maybe are not possible in the U.S. Where we sign away things to companies all the time, right? You get a Fitbit, you sign things away to Fitbit, to Garmin, to wherever. If speaking of multiple modalities, right? Like, if not only the hospitals, but various other companies that have relevant healthcare data, you could basically consent to that data being used for both research purposes as well as feedback to the healthcare system. I think that would be huge because we're developing tools on top of the data. But if we don't have the infrastructure to collect information, and especially on population scale, because if it is on some small groups of people, we know that we'll overfit to those people, the people who really like using those tools, and not to everyone in the population. So if we can build that substrate, that infrastructure, then we're in a really great place to, and then we have the checks, as you said. And maybe the checks keep increasing, right? Like, as people report that this system is not behaving the way I wanted it for me, then another question gets added to the test, right? So that's the infrastructure I see. And then, systems can be approved at different levels, right? That this is sandboxed at this level because it needs people with a high level of consent. It's kind of, very experimental. This is a system that has been shown, equivalent of a phase 3 trial at FDA. It looks safe, it looks effective. Now it's going to go out and we're just going to do basic post-market surveillance. But that infrastructure, I think, is what we need. And that's policy people, that's systems people. And then we're kind of just like, I don't know, almost the least important people in this ecosystem.
Yeah, we would hope that that's not the case. But so when you talk about infrastructure, do you mean like, would you have a local infrastructure for Korea or like parts of Korea? Or if you're talking about US, different states would have their own? Or were you talking globally?
I think that's a great question. I mean, to be totally honest, I think it's going to have to start out as smaller groups. Like, I'm on sabbatical in Singapore right now, and Singapore is a small enough place where there's a lot of integration that's being organized. I believe like other countries like Estonia, again, relatively small countries, have managed this. And maybe for larger countries, it's going to have to be regional. because I think that what makes it work is the vertical integration of multiple modalities for individuals. So if you have one modality across a large population, you probably are going to make less difference, have less opportunity than multiple modalities across a smaller population. I don't know, maybe others might disagree with that. Yeah.
Yeah, so, okay, so going back to the original question that I had asked Ed, so which is about your wishful thinking or your list of, like Santa's list or whatever. So do you have other things to add?
So I think that's my big list, a big item. I think it's a very big item. I would say on the technical side, if someone wants like a concrete technical question that they want to be able to think about and answer, I really think ways to validate models. When I work on interpretability, how to align the way that humans are thinking about models with the way that the models are actually working, or when the model says that I made this decision for this reason, does that match? Like when I say, because your t-shirt is red, is your version of red the same as my version of red? These sorts of things. So it's still a big question, like human and AI, mental model alignment, but maybe a little more technical, a little more something you can sink your teeth into.
Okay, and so we'll move now to the climate prediction side of things. So I know that you can compare to Finale and Ed is, or it seems to me, less on the machine learning side, more on the climate, actual like a domain expert, I think. So from a domain expert's perspective, are there specific modeling techniques or data sets or something that you wish that there was more of?
Yeah, I so before I said that there are plenty of observations we are having, but so the problem is that the problem is the independency between the data. So once we observe all the things which is happening today, so the number of data, it would be huge, but they are very dependent on each other. For example, once we observe the precipitation in South Korea, we can get many observations, but they are very much highly correlated. So we can get the problem is the independency. So to achieve that, to achieve the number of independent data, so the basic, so the ideally, so we have to generate the identical planet, which is exactly same as Earth, and yeah, try to test whatever we want. So that's the ideal way to we can get the data, but it cannot be happened. So it cannot never happen. So the problem is how to deal with the kind of data. So with the given or limited number of data. So I would say, so in our field, the most emphasizing is not the number of data, but the techniques itself. So the number of data is are limited, and actually it's kind of open to everybody. So we can freely download all the data which is observed from the satellite from the US and satellite from the Korea. So it's most of them is freely accessible. So problem is not the number of data and how to deal with the data with kind of the unique technique.
Okay, so I think that ties us nicely into my next question, which is about the machine learning models themselves. And since we have Finale and Ed who are experts in machine learning, maybe you can tell us either for healthcare or climate prediction what you think are the recent modeling techniques that have made important steps forward. And and this is also for the students who are listening to this who may not know the entire area of machine learning and do not really have the understanding of the different techniques in machine learning. So what are the recent ML techniques and advancements that you think have played important roles? What are our next steps? What are some of the most exciting directions that the ML community is going? Do you want to start?
I was hoping that Finale could go.
Okay.
Because what Yukun just said is very much related to counterfactual estimation, and maybe clinical trial has something to do with it. So Finale is a better person than I am.
Okay.
All Okay. So I agree. Like so okay, now I feel like we're in a much better or easier place than you are because when you have a true NF1 trial, because we have only one Earth, um, right? We at least have multiple patients to work across. Yeah, so I think this causality and counterfactual estimation, I think, are really important areas. So being a little bit biased toward the methods that I work on, but I feel like combining generative models that can be used to forecast the future and do these counterfactuals, but matching them to discriminative goals. So like one challenge we deal with a lot is that, especially when you start collecting lots of data across multiple modalities, you were saying that you don't know what matters, right? And you kind of put in everything hoping that you've caught enough of that. But then the hard challenge becomes how do you separate the relevant from the irrelevant, especially in the case where you don't want to get spurious correlations, especially in the case where you want the systems to be transparent, you want them to be interactive. So I'll say that that's maybe a key research area that has seen growth and I hope will continue to see growth in the future.
Do you want to?
So I I completely agree on the. I mean, I can't not emphasize more on the importance of causal analysis and counterfactual estimation. But since I'm not the expert on that, I would like to focus more on the engineering E side of things. So recently, we've seen a lot of success from using transformers on all kinds of different problems, not just language, but vision, time series, what have you. And I think we haven't seen the upper bound, like how large it can scale, like how much data can we put into transformers to saturate? And I don't think we've been there yet. So I think there's a lot more to explore on the potential like ceiling of transformer and what it can do in healthcare space, especially dumping all multimodal data at the same time to the single model. The problem is that, as Final and you just said, is that there's a lot of spurious correlation that could potentially harm people. You know, maybe even risk human lives. So the question is, how can we, if the transformer is like the ultimate scalable model that we have at our hands currently, then how do we guarantee some sort of reliability using transformer? Like there are a lot of different techniques for such as Bayesian neural networks or OD detection, anomaly detection, those kind of things that could somehow be used to guarantee some certain level of safety, but I'm not sure if we can directly use it on large scale, like GPT-3 scale model can be a nice fit to those kind of like lab tested uncertainty, like Bayesian models or OD detection models or that kind of stuff. So maybe we need like new ways to guarantee or at least facilitate reliability on huge models. And these days, I think people are just looking at the logits and then the entropy of the decoded generated text or generated sequence of tokens and see if which one is like the confident ones and which ones are not. I'm pretty sure that's not enough. So maybe a little more research needs to be poured into that aspect.
You want to add something?
I was going to say I agree with these complicated models. So another area that we haven't really emphasized, but we work a lot in uncertainty quantification. But it becomes very difficult because what does it mean to be uncertain depends on what you thought was possible in the first place. Like Bayesian reasoning is all about subjective probability. And so where do you start? And I think that has become very challenging as the models get bigger. So I don't have answers, but I think that's a really good point that you made.
Yeah, so there was a recent paper on language models, like how is the size of the language model, are these large language models being used to their full capacity? And I believe the short answer was no. The number of parameters is actually too large. And but these are very sort of small studies, or I mean, this particular study wasn't that small, but it was specifically for a number of language models and how they do NLP tasks. And so I agree with you in general, with these very large models that everybody's coming up with, we need a more systematic way of analyzing what's going on. What are the risks? What are the, uncertainties? Yeah. Okay, so I think we're actually at our next or last question. And if there are any audience questions, I think Slido is being used, but I don't see any questions so far. So if you do have a question, your chance is now to ask them on Slido. So we're going to try to wrap up. I think we've talked a lot about how the technologies are being developed. You're developing them yourself, but to actually get them to be used, we need a lot more collaboration, perhaps, infrastructure, ecosystem, transparency, interpretability, how humans, understand and use these predictions from the machine learning model. So from that perspective, and probably maybe a call to action to the ML community and the students who are listening to this, just give us your final thoughts.
As a climate scientist and atmospheric scientist, so I want you to put much more attention to tackling the climate change. So what I mean is that, so don't put them as a side work and try to understand deeply about the carbon cycles and the various climate variability to tackle this problem. So if your system might work once you put everything into your system, and you might get some desirable results. So that might be possible, but in my opinion, so that the process is not that it's not going on like that way. So we have to understand some kind of procedures to make a real progress. So for that, so we need to, so you need to, so we are tackling this problem very seriously. So, but we are very much new for the machine learning techniques, so we are now learning. And we are very serious about the machine learning technique too. So once you are interested in tackling the climate change and make a real change to reduce and understand the climate change, you have to tackle this problem seriously. So try to read some of the papers and about the carbon cycles and the global warming, and try to understand the basic concepts, how this works and what the effects of the global warming is. So I want you to emphasize that point.
Okay, so there's an audience question just about that, actually. And I also personally have this question all the time, right? So how serious is this climate change problem? We know it's serious. Do you have any specific numbers, or like, are we doomed to what do these machine learning models tell you about the seriousness of this problem?
So you mean the serious of the global warming or climate change? So I would say it would be very serious, because not only the warming of the global mean temperatures, so the effects are everywhere and ubiquitous. And so we are emphasizing that not only once the global warming happens, the occurrence of all the extreme events is now increasing. So we are finding the evidences, and all the climate scientists try to emphasize that point. And that might be well delivered to all the audiences and to the public. And we are emphasizing the impact of the global warming is really happening, and we are already experiencing all the impacts. And not only the general, the annual average temperature increase, but also the day-to-day variations. For example, the intensity of the precipitation and all the extreme events such as a drought. So in our area, Gwangju is now experiencing serious droughts from this year, and that kind of issues. So all the variations are mixed up. So we cannot separate the impact of the global warming perfectly, but doing the techniques using the machine learning and all the current methodologies we are using, so we are finding the evidences that that kind of extreme events is attributed by the global warming to some extent. So
Yes.
yeah. So to emphasize that point fully, so we have to separate all the climate variations from the global warming and see how the impact of the global warming without all the effects. So that kind of things is not possible in the real world. So that's where the difficulty comes from. So, but yeah, we are trying to find some evidences.
As Sonali said, we only have one Earth, right? And Ed, you want your final words?
Um, um, I think it would be good for the people to keep an eye out on what machine learners can do, especially in healthcare domain. So there's a very fine line between privacy invasion and getting your machine learning model performance up. I think there's a clear trade-off. Like if I provide more data, then the model's gonna get more information and then make more informed decisions. So I think there's an obvious trade-off, and then that kind of creates the tension. So I hope that the people can maintain a bit more like friendly or open mindset to what machine learning can bring in healthcare space, but also be vigilant because you never know. Like someone might be exploiting your data to harm on you. So just having like an open mindset, but also keeping an eye out would be like a good thing for what could happen in the next few years.
Finale.
Yeah, I'm going to echo what you all said. I think the biggest thing, especially if you're a grad student or an early career researcher in this phase, is to engage with the community find a community that you care about and engage. I'll be honest, I moved into healthcare after my PhD. And during my PhD, I had a bit of that machine learning, AI, computer scientist hubris of like, I'm just going to walk in and I'm going to fix everything. And I had my way of thinking about how things might go, and it turned out to be quite different. So whether it's a clinic or a hospital, maybe it's social services, this is AI for good themed in general, but find a partner that you can work with, spend time with them, as you're saying, like read the papers, whatever in the community. And you'll find that there are really interesting technical problems everywhere. Like I mentioned, I started out thinking that, the big problem is going to do RL for treatment selection. Now I work on RL for helping people make good decisions. It's still an RL problem. It's a very interesting RL problem. So I don't think you need to be afraid that by engaging, you're somehow diluting your, technical chops or something like this, which I don't know if you are. As a grad student, I'll admit I had that fear. But there is truly a way to be making good in the community and be doing things that you're passionate about, whether it's AI or machine learning or otherwise.
Very wise words. I think we all learned so much from this panel, so let's thank the panelists with a big round of applause.
Thank you very much. Now you may be seated. So the panelists shared their views on recent advancements and challenges in AI and ML for healthcare and climate change. I believe such precious ideas and insight will be added up together, and it will foster the further advancement of AI-related technologies. Thanks again to Professor Oh and to our panelists for such an informative discussion. And next, I'd like to move on to the keynote speech. And for that, please allow me to introduce Lee-Dong Zhou, Corporate Vice President of Microsoft and Managing Director of Microsoft Research Asia. He'll be talking about innovating for the future of humanity. But before we start, we ask for your kind understanding that we might experience an intermittent disconnection since Dr. Lee-Dong Zhou will be presenting virtually. So Dr. Lee-Dong Zhou, please let us know once you are ready.
Yep, thanks for the introduction. I hope you can all hear me.
Yes, we can hear you very well.
Great. Yeah, it's a really honor to present at Korea AI Summit. I'd like to thank Professor Lee for inviting me. And I was actually hoping to be there in person, but unfortunately there was actually a conflicting schedule. I had to be back in US, so I missed the opportunity to be there in person. And I actually did pass through Korea, and this is the photo I took when my plane landed at the Incheon airport. So I was actually close. So hopefully next time I'll be there in person. So I will start with our view of the future. I have to say, we're really living in a very exciting time. And I think we are at the Xerox PARC moment of a new computing paradigm for the coming decades. You may ask what I mean by that. So if you look at the history of computing, right, even in the first digital computer, ENIAC, was actually started in 1943. Actually didn't get finished even after the World War II. And at that time, computing was actually reserved for scientists to do very complex numeric computation. But in 1970s, something dramatic actually happened. This was a photo of Alto, which was the first personal computer. It was made at Xerox PARC. Along with Alto, there were a series of other innovations that actually really started the era of personal computing. And we're talking about all the things we're familiar with. What you see is what you get, kind of a GUI interface. And we're talking about mouse. We're talking about all the Ethernet, laser printer, all those technologies that we're familiar with. Even today, we are still living in the same personal computing paradigm. We do have smartphones, but in terms of how we interact, nothing fundamental has changed. But what we believe is this is going to change as early as next year. So we're going to see an emergence of a new computing paradigm empowered by all the advances in computer science, especially in artificial intelligence. And you may ask why you think there is going to be a new paradigm. And the way we judge whether a new paradigm emerges or not is to look at the role of computing in our lives and in our society. Let's see whether they are actually fundamentally different. Just when we entered the personal computing era, it wasn't really only for computation, numerical calculation. It was actually for a lot of things we do in our lives, in an office, right? The project was actually started to create this vision of paperless office. And also, the major change that happened there was how we actually interact with computing. But if you look at today, there are at least 4 major changes that are actually happening. The first is sort of emergence of general intelligence. We all know the power of those large language models. And it turns out that those language models are now capable of doing much more than just language. We're talking about multimodality. We're talking about being able to process images, music, all kinds of modalities. And that completely changed how we actually interact with computing, because now computers can actually understand us through natural language. We don't have to go into the computing world, speaking the language that computers speak. We can actually use our own natural language. And that's actually a major shift. The other thing is, we have all the ability to sense the world, and we can virtualize the real world. And that, and also not only sensing the world, but also be able to understand it and act in it. And that creates, many different forms of interactions that's, much richer than before. And the third thing is, we are actually also always creating this virtual world that's actually now increasingly realistic. We're talking about, 3D, very immersive kind of experience that allow us to transcend time and distance, all the physical constraints that we live in our real world. And finally, computing is no longer constrained in devices. When we do computing, we usually open our laptop and smartphones and things like that, and that's how computing happens. But we're seeing a major trend of, a shift where computing is pervasive, it's contextual, it's actually everywhere, whenever we need it. And so what are the major opportunities this kind of paradigm shift brings us? This is actually a major opportunity that we should all think about, how we can actually create that opportunity, also leverage that opportunity to do what's good for the society. And here I want to emphasize, some of them, just to give you a sense of, what's going to be different in the new paradigm. And the center of this is the emergence of general intelligence. And here we're actually seeing a big convergence in terms of deep learning, right? If you look at all the fields that used to be separate, we're talking about natural language understanding, we're talking about computer vision, we're talking about multimedia, we're talking about graphics, and now deep learning becomes the foundation of all those domains. The methodology becomes very much the same. And even if you look at deep learning, we're actually converging towards transformers, as sort of the model architecture. And it used to be that we actually develop a model for each task. Now we're actually seeing the emergence of what we call foundation models that can actually take on many different tasks. And that's what we call the emergence of general intelligence. Think about the possibility of creating an intelligent agent, just like you have seen probably ChatGPT, that can more or less operate at human intelligence level. And that has deep implications on the future of computing and also on the future of humanity and the future of our society. And of course, there are still a lot of unknowns, right? Especially on the foundations for this kind of intelligence. The people have been complaining, we don't understand, why those models work and how it works and where it doesn't work. So there's this complaint about this whole area remains an alchemy. And if you look at the history, there was actually a long, probably 200-year process of going from this alchemy, which is really practice, but without a theory, into a science of chemistry. So going forward, we definitely see the same trend happening. That is, we're going to build the science behind the intelligence, the general intelligence that we're going to witness. And if you look at all those powerful big models, they're huge, and they're very slow in terms of training and inference, and then also they take a lot of energy. And if you compare to the scale and the energy efficiency of human brain, for example, you can see orders of magnitude gaps in terms of both scale and also efficiency. So there needs to be a lot of work that develop new methodology, abstractions, and tools. And also look at the co-design of hardware and software in order to close that gap, so that AI can be pervasive, right? Given the current energy cost, it's just not possible for AI to be applied in our daily lives, in all scenarios that we actually care about. And another thing that's also important is we see a lot of new development in sensing technology. And we started with all of the cameras, but we're going much more beyond vision. Right? We're talking about a lot of wireless sensing technologies that are actually becoming more and more mature, and they become more pervasive. And all those sensing will become continuous and will come in multimodality. It's just like human beings, right? We have multiple sensory capabilities, and all those signals will get merged together for us to figure out what's going on in the world. And that's definitely going to happen in technology as well. And there are also very interesting application areas to solve real problems, right? And if you look at the AI field, we started with a lot of benchmarks. And like all the creative work that happened in the last 20 years can be contributed to some of the very well-known benchmarks like ImageNet. But when we talk about applying AI to real problems, it's much more than just achieving SOTA results on a leaderboard for a certain man-made benchmark. We're talking about dealing with all kinds of problems in real life. The data may be noisy, there may be limited, and the applications require multiple sources of sensing capabilities in order to solve those problems. And how we actually make sense of not just vision or not just natural language capabilities, but the general understanding of what's going on, that's actually very important. So we're going to actually make that transition from what we call academic AI to really industrial AI, so that AI can actually really be applied in real scenarios. And another thing that's actually also very important is human beings just crave for those kind of realistic 3D remote immersive experiences, right? And not, it's probably better than what you experience now as I'm, talking from United States. And that requires a lot of work in, graphics, in video codec, and all those fields will actually be revolutionized by AI technology, so that this more realistic 3D experience become feasible. And another important area that actually we're seeing a lot of excitement in AI generated content. But fundamentally, think about us, human beings. Curiosity, creativity, imagination are what's making our life meaningful, fun, and interesting. And we're seeing the ability of AI to augment our curiosity, creativity, and imagination in ways we actually never expected before. And certainly, those have deep implications on how we do creative work. And if you think about, AI is actually not something that that we do in isolation, right? Certainly, there are a lot of applications, for AI, and people are talking about AI for science, for example, because with new methodology enabled by AI, a lot of natural sciences will actually develop a new methodology, right? We actually have new discoveries powered by the new AI capabilities. And more interestingly, if you look at neuroscience, it's actually going both ways. In one way, we are actually enabling neuroscience to understand how our brain works in interesting new ways, inspired by neural networks, or using neural networks as tools. On the other hand, our increased understanding of neuroscience also helps us develop better models, develop better neural architecture. But what's most interesting, and I think we're not paying enough attention yet, is how AI interacts with humanity. And when we are getting to witness the emergence of general intelligence, I think that becomes a center of the problem. And we're not just talking about, how the humanity disciplines going to be affected by artificial intelligence. We're talking about things that are probably much more profound and much more fundamental. For example, we can even ask the question, what is intelligence? Right? Is intelligence, we always think intelligence is how, we actually get distinguished from, animals and others. But now if we have AI, do we understand the essence of intelligence? And does AI need to have human values? What value systems should AI have? And what's the implications of having all those kind of general intelligence? Right? That could actually change different parts of the society in many different ways. And that study cannot be done only in computer science, right? It requires really interdisciplinary research with many other areas like psychology, social science, and so on. And one fundamental question that we may ask is, we are talking about developing technology that really is going to be very disruptive. It's going to be transformative of our society, right? And people earlier were talking about how we deal with climate change, how we deal with health. So the important thing that we should keep in mind is that we certainly can develop technology to do a lot of different things, but we really should think about what technology should do, right? Since theme of this AI summit is AI for good, so it's actually very important to ponder on this question. Now, I'm going to actually use some examples just to demonstrate some of the work that we've been exploring to see how we can use technology, especially AI, to do breakthroughs to actually good to people. And the first thing I want to talk about is more along the lines of cultural heritage. And what's actually particularly interesting here is, in many, for human beings, we have a long history, and sometimes we don't really understand how our culture actually evolves over time. And I'll use this one example. This is oracle bone restoration and curation. And this is actually a language system. It's probably one of the earliest language system that's actually in the Shang dynasty. That's about 3,000 years ago. So we have all those inscriptions on oracle bones. And now the grand challenge is how we can decipher those 3,000 mysterious characters, right? Remember, those oracle bones are 3,000 years old. And so it's actually a miracle that we can still see a lot of things on those oracle bones. And what's interesting is that it's a way for us to understand the evolution of the language system, right? From oracle bone, what's on the oracle bone to today's Chinese, for example. And so what is an interesting problem in that space? So the way it works is, certainly we don't just look at the real oracle bones. There are a lot of what we call inscription rubbings. So you just get what's on the bone, on paper. And different people can get different, inscription rubbings. And after a while, there are just multiple copies of, everything. And they come in different forms, and there are maybe different pieces of the same thing. And this is what all the scholars use to study the oracle bone and all the characters on it. So that becomes sort of the ground truth. And an important problem is to actually do duplicate detector. So we look at all those inscription rubbings. We need to connect them together so that we can actually restore those oracle bones to the maximum extent. So for example, we start with some local image patch. So what we do is we want to simulate all the things that could happen to that image. So to get the different variations, we call image augmentation. And then we use deep neural network to really figure out some of the sort of invariant feature representation. So the way it works, usually is you really want to match two rubbings, but it's actually very hard to do if you just do it globally, because they be distorted in different ways, and it's actually very hard to match a point on one to another point in another one. Not to mention you have to do this globally. But there are actually a lot of advances in AI that does unsupervised learning, right? So what you can do is you can actually use unsupervised learning to find all the correspondence point by point locally first, and then evaluate globally how similar those two rubbings are and whether you can match them up. Of course, I'm describing it at a very high level, but there are a lot of interesting technology that needs to be developed in order for this to work. And this also has to be done with experts in the domain. So in this particular case, so we have a researcher, CH01 Wu, who is actually an expert on self-supervised learning for computer vision. And he's working with Professor Mo from Beijing Normal University on this particular problem. And Professor Mo is actually a Shang scholar, specialized in oracle bone and detection and so on. So we'll show you some examples, how this works. So those are, for example, two rubbings that are in the record, right? So now the question is, are they rubbings of the same piece? Are there overlaps? Are there duplicates? So using the system, you will first try to match them point to point locally. And then you see the correspondence that it was discovered. And this is actually done by deep learning. And think about how hard it is for human beings to do it, using your eyes. And once you find enough matching, you can actually evaluate the similarity, and then you find out they can actually be put together into one piece. And that stitching together is also done through the system. And of course, then the domain expert can verify whether this is a good match or not, which is much easier to do than try to figure out how whether there is any duplicates. And there are certainly more complicated cases, right, where we have those three pieces, and again we try to do the local matching, and there are some incorrect local matching, or local matchings that are not really useful. But you can see the density of the local matching where there is a duplicate. And turns out, those three pieces can actually be stitched together into one. And so what's interesting is, the system has been applied on like 180,000 of those rubbings, and found at least 300 new kind of duplicates that you can merge together, and even detect some of the incorrect ones, which is actually a major paradigm shift for people who are working on oracle bones. For them, this is really a new methodology that can really advance how they study oracle bones. So the other set of examples I want to actually talk about is health for the underrepresented. If you look at AI in general, we're talking about natural language, we're talking about speech, we have made a lot of progress on video. All those work, are usually focusing on normal people, right? We're talking about, doing translation, doing speech recognition. That's certainly bring down the barriers among people. We're talking about normal people. But it's actually important for us to also be inclusive when we apply AI and think about how AI can benefit those who are underprivileged, who are underrepresented. So I'll give you a couple examples from the projects that we have been working on. And the first problem is for people with cleft lip and palate. And it turns out to be not a rare problem. More than 1 out of 1,000 newborn babies will actually suffer from cleft lip and palate. And in total, we're talking about tens of millions of people worldwide. And for those babies, at some point, some decision needs to be made. So one of the decisions is whether they need surgery or not. And the other decision is whether they need speech therapy, right, to help them recover. And that assessment is actually hard to do in general. So you really need trained, skilled doctors. But we don't have enough of those experts to do the assessment. And this is where AI technology, especially given all the advances in speech recognition, speech analysis, can be truly helpful. Right here, we're really looking at the acoustic features. But what's interesting is it's not the same problem as traditional sort of speech recognition, right? We're talking about a special group, which is a minority group, and their acoustic features are actually very different. And also, we don't have a lot of data on those people because it's a minority, and it's a common problem, for the underrepresented, right? Because we don't have a lot of data and to help them. So there's a small data problem that we have to solve. But fortunately, this is clearly solvable. And the other thing that's also important when we apply our technology in the health domain is we have to be able to explain the result. And that's another requirement that we need to work on. So what's interesting to see is, of course, we are really motivated to help those people who are really in need. But at the same time, looking at those problems also helps advance the state of art in AI. So we have to solve those problems. And this is also some good examples of how we go from academic AI to really practical, realistic, what we call industrial AI. So we have to solve real problems. Fortunately, in this case, we're able to, with innovations in AI, we're able to match the human expert level. And that will be tremendously helpful because now we can help a lot of patients with AI, even though, we don't have enough doctors. And another example is, think about our society. We're actually getting a very, aging society. And one of the key problem is a lot of people actually suffer from Alzheimer's disease, right? And this is actually a pretty painful, slowly deterioration process in our cognitive capabilities. And in order to diagnose for this kind of AD, one of the issues is how can we do this in a very affordable, accessible, and hopefully non-intrusive kind of way. We don't have to do a lot of lab tests and things like that. And it turns out that we can use speech and language, right? Those are actually cognitive capabilities. The question is how we can accurately detect AD. And it turns out that there is this descriptive tasks, right? You basically look at the image on the left, and you ask a patient to describe what's on the image, and depending on the words they're using, also some of the speech features or linguistic features, language features, we are able to actually distinguish those who are actually suffering from AD and so those who are not. And again, that's tremendous helpful in many dimensions, right? So now we can have a very cheap way of doing diagnosis. So we can do early prevention and try to help patients recover. And so another group of people suffer from autism spectrum disorder. And for those people, what's important is we need to, again, detect ASD. And the way to do that is to monitor and also analyze those stereotypical behaviors. If you detect that, then we can do early intervention, and then we can figure out how we can take care of them. Again, we're suffering from the same problem because we don't have a lot of videos that with all the supervised data, right? We can't do supervised learning because we don't have enough data that can tell us which is stereotypical, and there are also different variations of stereotypical behaviors. But again, we have this approach of using self-supervised or unsupervised learning that can actually detect stereotypical behaviors without someone has to mark a lot of videos up, because it's not a very scalable way of doing that. And this is one of the things that we're able to do using AI technology, right? We just look at the video. Again, we have a lot of technology on doing video analysis. Now we're applying those technology onto this particular domain, and of course, there are specific challenges that we have to address in order to help those in need. So those are just 3 examples that we're using, and I know my colleague Ranvir is going to give another keynote on what we do in agriculture, and we also have a lot of work on how we fight climate change. But I hope you get a sense of how we think about AI for good, especially in the larger context of the company. In fact, Microsoft has been committing $125 million to really not only for us to do this kind of AI for good work, but also to empower organizations around the world to solve those really challenging societal problems. That includes, environmental problems, humanitarian issues, accessibility, health, and cultural heritage, all the, social good that we could do. And I'll just end here, and I'm happy to take any questions you have. Thank you very much.
Thank you very much once again. So Dr. Zhou talked about how AI will impact our humanity in the future. So now I'd like to get questions from the floor. If you have any questions, please raise your hand. Any questions? Yes, please.
Hi, Dr. Zhou. David Ryder from Google Research in New York. I think you alluded to it at some point. In your view, what's the importance of theory building that helps us understand not just how well, but frankly, how AI and these deep models go about solving problems so well?
Yeah, that's excellent question. Thanks, David. I think we have seen some work along those lines, right? I mean, there are many aspects of deep learning that people try to understand. I think I would refer to Sebastian's work. I think last year's NeurIPS, I think, as a good example for understanding the robustness of large language models. And in that paper, he actually pointed out that in order to achieve reliability in those models, you really have to get to a certain number of parameters, right? It's actually much larger than originally we originally thought. For example, for 10 million images, it's actually not 10 millions, but you have to go 1,000 times higher. And that kind of theoretical understanding lay out some of the foundations. It's just one aspect, right? And there are many aspects of try to understand when a large model actually works well and when a large model doesn't work well, and what are the sort of weakness of some of the models. I think we're at the very early stage of understanding those things. I'm not an expert in this domain, but I've seen very promising work along those lines. And Sebastian's work is just one example of that.
Thank you very much. I hope it answered your question. So I'd like to get one more questions. If you have any questions, please feel free to ask. Anyone? I'd like to see whether there is any question we received online. Okay, thank you very much. Then now we'd like to wrap up there. Thank you very much once again for your insight, Dr. Zhou. And that leads us to the end of keynote speech session. And thank you very much. The opening ceremony will begin shortly, and before that, we'd like to take a short time to set up for the ceremony, so we ask you to remain seated, and we will begin the ceremony in a few minutes. Thank you very much. Ladies and gentlemen, may I have your attention, please? The opening ceremony of the Korea AI Summit 2022 will begin shortly. So please come inside and be seated. Thank you very much. Ladies and gentlemen, may I have your attention, please? The opening ceremony will begin shortly. Please come inside and be seated. During the event, please make sure that you wear your mask properly to comply with the COVID-19 preventive measures. And we would appreciate if you could turn off your mobile phone or put it into silent mode. Thank you very much. We'd like to get started, so please come inside and be seated. Distinguished guests, ladies and gentlemen, now let us officially commence the opening ceremony of the Korea AI Summit 2022. My name is Ji-young Park, your MC for today's event. First and foremost, thank you very much for coming to today's event. Today's conference is hosted under the theme of AI for Good, aiming to allow everyone to think about the present and future of artificial intelligence technology and its related challenges and countermeasures by having a close look at examples and insights shared by AI experts at home and abroad. Today's conference is being broadcast on our YouTube channel as well as our Naver TV channel. And before we begin, I'd like to introduce our distinguished guest joining us here today. So please welcome each and everyone with a warm round of applause. First of all, we're joined by Sung-bae Chun, President of the IITP. Please welcome him with a big round of applause. Commissioner Sung-wook Park of AI and Innovation Hub and Vice Chairman of SK Hynix. Thank you very much for your presence. We're also joined by Ranveer Chandra, CTO of Agri-Food, Managing Director of Research for Industry and Head of Networking Research at Microsoft's Research, Redmond. Thank you very much. And we have Professor Sung-hwan Lee from Korea University, and he is the executive organizer of today's event. Please give him a warm round of applause. And lastly, although there are more distinguished guests whom we'd love to address, but due to time constraints, we ask for your kind understanding that we cannot address them all. And thank you for your participation. And next, I ask everyone to stand up and join me in the Pledge of Allegiance. Please stand up, everybody. And please look at the flag in front of you. Salute to the national flag.
나는 자랑스러운 태극기 앞에 자유롭고 정의로운 대한민국의 무궁한 영광을 위하여 충성을 다할 것을 굳게 다짐합니다.
At ease. Thank you very much. Now you may be seated. And now, distinguished guests, allow me to invite Professor Sung-hwan Lee, the General Co-Chair, to give opening remarks. Please welcome him with a big round of applause.
안녕하십니까. 과학기술정보통신부가 주최하고 인공지능 혁신허브, 마이크로소프트 리서치, 정보통신기획평가원 및 고려대학교 인공지능연구원이 공동으로 주관하는 코리아 AI 서밋 2022에 귀한 걸음을 해주신 여러분을 환영합니다.
Good morning and welcome to the Korea AI Summit 2022, hosted by the Ministry of Science and ICT and co-hosted by the AI Innovation Hub, Microsoft Research, Institute of Information and Communications Technology, Planning and Evaluation, and AI Research Center at Korea University.
AI for Good이라는 주제로 인공지능의 현재와 미래를 고민하고 나아갈 방향을 함께 모색하는 유익한 시간을 준비하였으며 국내외 AI 전문가들을 모시고 분야별 연구 동향을 파악할 수 있는 의미 있는 시간이 될 것으로 예상합니다.
Under the theme of AI for Good, this year's conference will suggest the current status and future of artificial intelligence, also allowing everyone to seek future directions altogether. And I believe it will be a meaningful time for us to explore the current research trend in various areas with AI experts at home and abroad.
귀한 시간을 쪼개어 자리를 빛내주신 정보통신기획평가원 전성배 원장님, 2022년도에도 고위험 도전형 연구에 매진하신 AI 혁신허브 세부 책임 교수님 및 연구원들과 온라인으로 이 자리에 참석하시는 여러분들께 감사의 말씀을 올립니다.
And I'd like to express my gratitude to President Chun Sung-bae of the IITP and professors as well as researchers of the AI Innovation Hub who have worked hard on high-risk and challenging research, as well as all the participants for taking time out of your busy schedule to join us.
유익한 강연을 준비하신 키노트 연사인 마이크로소프트의 리동조우 연구소장님, 람비어 챈드라 박사님, 코넬 대학의 존 호프크라프트 교수님을 포함하여 세계 각국의 40여 분의 연사분들에게 참여해 주셨지만 한 분 한 분 다 소개를 못하는 점 양해 부탁드립니다.
And I also would like to thank all our renowned speakers from countries around the world. There are a lot of distinguished speakers from overseas, so I won't be able to address them all, but I'd like to thank all the speakers, including our keynote speaker, Lee Dong-jo, Corporate Vice President of Microsoft, and Dr. Ranveer Chandra, as well as Professor John Hopcroft from Cornell University.
아울러 본 행사를 풍성하게 만들어주신 마이크로소프트 리서치 이미란 전무님, 조직위원님들과 스텝 여러분들께도 감사의 말씀을 드립니다.
In addition, I'd like to thank Ms. Miran Lee at Microsoft Research, the organizing committee, as well as all the staff members for making this event even more fruitful.
4개월이라는 짧은 시간 동안 준비하여 미흡한 점이 있을 것으로 생각됩니다. 미리 너른 양해를 구하며 14일과 15일 양일 동안 개최하는 본 행사에 참석하신 모든 분들께 연구력 제고의 기회뿐만 아니라 국내외 연구자들 간의 활발한 교류와 인재 양성 등을 위한 협력 방안을 논의할 수 있는 기회가 되기를 바랍니다. 감사합니다.
Since we were given only 4 months of preparation, I'm afraid there could be things that are insufficient. So we ask for your kind understanding in advance. And during this 2-day conference, which will take place today and tomorrow, I hope the conference will not only be a venue for researchers to gain insights, but also a place where you can discuss ways to better cooperate in fostering talents. Thank you very much. Thank you very much, Professor Sungwon Lee from Korea University. And now, please allow me to invite President Sungbae Chun from Institute of Information and Communications Technology Planning and Evaluation. He will deliver his welcoming address. Please welcome him with a big round of applause.
안녕하십니까. 정보통신기획평가원장 전성배입니다. 2022년도 인공지능 혁신허브 코리아 AI 서밋 2022 개최를 진심으로 축하드리며 뜻깊은 자리에 참석하게 되어 매우 기쁘게 생각합니다.
Good afternoon, ladies and gentlemen, distinguished guests. I am Sungbae Chun, President of Institute of Information and Communications Technology Planning and Evaluation. I'd like to congratulate you on hosting the 2022 AI Innovation Hub, the Korea AI Summit. Also, I am very delighted to be here today.
먼저 바쁘신 일정에도 불구하고 이 자리를 빛내주시기 위해 참석해 주신 AI 혁신허브 연구 책임자 이성환 교수님과 박성욱 AI 혁신허브 운영위원장님, AI 혁신허브 과제 참여 교수님들께 감사 말씀을 드립니다.
Professor Sungwon Lee, General Co-Chair of the AI Innovation Hub, Sung-Wook Park, Commissioner of the AI Innovation Hub, and all the professors who have participated in the AI Innovation Hub project, thank you very much for coming to today's conference out of your busy schedules.
그리고 대학 현장에서 인공지능 분야의 인재 양성과 차세대 인공지능 연구에 노력하고 계시는 많은 교수님들의 노고에 깊이 감사드립니다.
Also, I'd like to express my deepest gratitude to university professors who, for their dedication to next generation AI research, as well as their commitment to nurturing the talented younger generations in the field of artificial intelligence.
AI 분야의 기술패권 경쟁이 가속화되는 가운데 세계 각국은 인프라 구축과 도전적 연구개발에 대규모 투자를 단행하고 기술 주도권 확보를 위해 각축을 벌이고 있습니다. 우리나라도 전 세계적인 추세에 발맞추고 기술적, 과학적 난제 해결을 위해 지난 21년 AI 혁신 허브 사업을 시작했습니다.
With the growing competition in the field of artificial intelligence, countries around the world are making large-scale investments in securing infrastructure and R&D to gain the upper hand in the fierce competition. We, South Korea, also launched the AI Innovation Hub project in 2021 to meet the global trend and to deal with technical and scientific challenges.
AI 혁신 허브 사업은 대학과 기업, 연구소 등 개별 주체가 수행하기 어려운 고위험 도전형 연구개발의 중심의 최고급 인재 양성을 지원하고 있습니다. 또한 개방형 연구체계 구축과 다양한 컴퓨팅 자원의 연계 활용 등을 통해 국내 AI 기술의 역량을 높이는 데 기여를 하고 있습니다.
The AI Innovation Hub supports nurturing top-notch talents with high-risk and challenging R&D projects that are difficult to be conducted by single entities such as universities, companies, and research institutes.
주관기관인 고려대학교를 비롯한 총 12개 대학이 기업들과 협력 연구를 통해 204편의 우수한 연구 논문을 발표한 바 있습니다. 더불어 다양한 기관과의 개방적 연구 수행을 위해 내년 1월에는 AI 데이터 센터를 개소할 예정입니다.
In such a context, a total of 12 universities, including Korea University, which is one of the organizers, have carried out joint research with private businesses and published 204 research papers. And in January next year, the AI Data Center is scheduled to be opened for open research with various institutions.
올해 처음 AI for Good을 주제로 개최되는 코리아 AI 서밋 2022에서는 AI 혁신 허브 사업의 주요 성과 소개와 함께 인공지능의 효율성, 책임성, 확장성을 공유할 수 있는 명사 강연과 패널 토론이 진행될 예정입니다.
At this year's Korea AI Summit 2022, which is being held under the theme of AI for Good for the first time, you'll be able to see AI Innovation Hub project's major achievements and take a close look at efficiency, responsibility, and scalability of artificial intelligence that will be discussed during the lectures and panel discussions.
본 행사가 인공지능 연구의 현재를 통찰하고 미래 발전 방향을 모색하는 데 좋은 기회가 되기를 기대합니다. 저희 정보통신교육평가원도 보다 많은 인공지능 연구자들이 함께 협업할 수 있는 기회를 만들기 위해 노력하고 지속적인 지원을 아끼지 않겠습니다.
I hope this conference will serve as a good opportunity to comprehend the present of AI research and explore the future direction. The IITP will also spare no efforts to offer more opportunities for AI researchers to work together and support them.
다시 한번 코리아 AI 서밋 2022의 개최를 축하드리며 참석하신 모든 분들의 건승을 기원합니다. 감사합니다.
Once again, congratulations on holding the Korea AI Summit 2022, and I wish the best of luck to all the participants. Thank you very much. Thank you once again for your words. And President Sang Hui-chan, please remain on the stage as we are to take a group photo with the participants. Now it's time for the group photo to commemorate today's event. We will be divided into 2 groups and take pictures 2 times. So as our VIPs have gathered, we will take a picture together. So while expressing our deepest gratitude to all of you who are working tirelessly for the advancement of AI-related industries, let us pose fighting pose. Fighting? Open my count. Yes, fighting. That's tradition of South Korea. Please look at the camera. And 1, 2, 3, fighting! Once again. 1, 2, 3, fighting! Thank you very much. One more. Last one. Please look at the camera. 1, 2, 3, 화이팅! 네, 감사합니다. Thank you very much. So we will take a picture with our distinguished guest. So those of you who have your name tag on your table, please come forward. If your name tag is on your table, please come forward to take a group photo all together. And once again, and I ask all of you to pose fighting again this time. Don't be shy. Please look at the camera in front of you. We will take a photo once everybody is ready. 네, 준비 되셨을까요? 네. 준비됐을까요? 네, once again, thanking all the AI industry insiders, we'd like to pose fighting again. 1, 2, 3, fighting! Thank you very much. Once again, you can take off your mask. And we will take another one without our mask. Let us smile for the first time. 1, 2, 3, and another fighting pose. 1, 2, 3, fighting! Thank you very much for your cooperation. Now we'd like to wrap up there and you may return to your seats. Thank you very much. I hope it will be a great memory for everyone. And that brings us to the end of our closing ceremony. And at 2 p.m., presentation sessions will take place at Grand Ballroom, Studio 1 and Studio 2 and 3, Studio 4. Each session will be broadcast online and you can check the channel information on our official website. Thank you very much, everyone, for your participation, and I'd like to say goodbye here. Thank you very much.